So here we are going to discuss about NR waveforms, that is modulation schemes used for 5G NR. So first we'll discuss about OFDM based waveforms. As we are using OFDM in LTE in downlink, we are also using OFDM with some extended versions of OFDM depending upon the use cases in NR. So if you consider 5G downlink and uplink for EMBB, enhanced mobile broadband, and URLLC, ultra reliable low latency communication, they use cyclic prefixed OFDM. So for 5G downlink and uplink, especially for if you are using EMBB and URLLC use case, we use cyclic prefix OFDM, CP OFDM. As we have already seen, spectral efficiency is better than LTE, typically
Synchronization
95%
is better than
NR.
LT.
So coming to next type of modulation scheme, which is a basically OFDM modulation only, but DFT-s OFDM. So this type of modulation scheme is optionally used. We can use or we may not, but we can use DFT-s OFDM in uplink for single layer transmission, especially for simpler power efficient devices. So these are the modulation schemes used in NR. So we'll see each of these modulation schemes in detail.
Yep.
Coming to OFDM cyclic prefixed, that is CP OFDM. So basically orthogonal frequency division multiplexing is a multi-carrier modulation techniques. A complete wideband channel is converted into narrowband subcarriers. So they are saying treats a data stream as a multiple parallel narrowband signals. Multiple narrowband signals are transmitted at the same time. So how these subcarriers can be generated? These subcarriers can be generated using one of the important mathematical and signal processing tool, that is inverse fast Fourier transform. So using inverse fast Fourier transform, there are a lot of advantages. What are the advantages? The main advantage is the shift from analog to digital. So if we are using analog modulation circuitry for this OFDM, as we know there are multiple subcarriers. To modulate each subcarrier, we need different n. If there are n number of subcarriers, we need n number of local oscillators and n number of mixers,
Ch-
and the hardware complexity will increase. But by using IFFT, these all can be reduced. So there is no need of additional circuitry. And this inverse fast Fourier transform helps the channel to convert from linear convolution to circular convolution, which is more efficient. And multipath fading occurs due to delayed signals. A single signal, it arrives at the receiver side with a different time because of this fading effects, non-line of sight components, and non-orthogonality, and cyclic prefix. Cyclic prefix is nothing but the last copy of symbol is added at the first, so that when two OFDM frames overlap with each other, there will be no loss of information. There will be no interference. Even though there will be interference, even though they overlap, the last symbol of first OFDM frame and first symbol of second OFDM frame, even though they overlap, we have another copy suffixed at the beginning. So it has a good throughput because parallelly we are transmitting, and it has high data rate. So this is about cyclic prefixed OFDM. Next is DFTs OFDM. This is specifically used for uplink when when power is a main factor. Means low power devices, when we are using low power devices and we use a 5G network, we need DFTs OFDM. Why we are using this DFTs OFDM? Because as we know, the main disadvantage of OFDM is high peak to average power ratio.
Okay.
This high peak to average power ratio we can't afford in uplink, because uplink, as we know, that it is the transmission from user equipment to base station. UE can't pump that much amount of power. UE can't afford that much linear power amplifiers. UE can't afford dynamic range ADCs, because UE is a small power or battery limited device. So OFDM can't be used in uplink. So instead of OFDM, we are using DFTs. Before going for orthogonal frequency division multiplexing, we are doing discrete Fourier transform and then spreading it. That is, DFTs OFDM reduces PAPR by spreading symbols. Symbols are spread across subcarriers. So it is also low complexity, transmission power required will be less, and low cost. So before using OFDM, that is before using IFFT, we are performing DFT. So it is creating, means it is a creating a scenario like single carrier modulation scheme. So for single carrier modulation, PAPR is very less. So this is the advantage of DFTs OFDM, and hence it can be used for uplink in NR. So in simple words, we can say downlink and uplink, we can use cyclic prefix OFDM to maintain orthogonality and to reduce interference. For if you want only uplink only, that too for when power is main concern, and we have battery limited devices, then we can use DFTs OFDM. Okay, stop.